Okay, so we just talked about how when we implement regularization, our cost function is going to look a little bit different. And it turns out for gradient descent, it actually looks pretty similar, but when we take the derivative of our cost function, specifically when we're changing our parameter w, there's going to be another term added. So all this is now, when we take the derivative of our cost function, it's going to be what we originally had plus lambda over the number of our data points times our parameter. And note that we don't actually have to add such a term when we're changing our parameter b because we don't regularize b, so no additional term is needed here. So when we plug this back into gradient descent, we get this. We can actually visualize what exactly this additional term is doing by rearranging this line over here. Okay, so all I did is just rearrange that line, and we can see that this portion is equal to this. And this portion over here is just our usual gradient descent update for unregularized linear regression. Really, the only thing that's changing is when we distribute wj to this term. So the only change in our updated gradient descent is the term wj times negative alpha, so our learning rate, times lambda over m. And we can further visualize what this exactly is doing by plugging in appropriate values for lambda, alpha, and m. Okay, so a learning rate of 0.01, a lambda value of 1, and a number of training data points of 50 are all very appropriate. So we can see that when we substitute these values into this term over here, we get this, which is equal to 0.002. And finally, when we substitute all of this back into this term over here, we get that. And this is equal to 0.998. So you can see that this regularization term, what it really did in gradient descent is for each iteration, it made wj be multiplied by a number slightly less than 1. So in this case, 0.9998, which has the effect of shrinking wj over time. And remember, we talked about how regularization attempts to minimize our parameters. So we can see its effect in gradient descent here. Another thing I'd like to go over with you guys is how we get the derivative term. So how exactly we get this term over here. Well, this is what it looks like in its full term. Okay, so remember, this is what the cost function looks like. And by the rules of calculus, when we take this derivative, we actually get this, where now we have this value of 2, and it turns out these values of 2 cancel out, and so do these values of 2. And now the summation that was present over here actually isn't present anymore. So when we simplify this, we actually get that. And remember, w times x is just our model, so we can substitute that with f, and we finally get this, which is what we saw up over here. So hopefully that makes a bit more sense to you now.